Hello students, welcome back to my channel JP Physics. In last lecture we have discussed about the application of circular motion, that is motion of a vehicle or a car along a horizontal circular path. In this lecture also we are going to see another application of circular motion, that is well of depth, or you can say also wall of depth. Well of depth, that is मौत का कुआं. Well of death, in this you might have been seen that motorcyclists make the stunt in a cylindrical well or a circular path. He is making horizontal circular motion along a cylindrical path. For that motion, which speed he has to maintain or which speed he has to acquire so that he is not going to slip or not going to skid, that minimum velocity we are going to see in this expression. So let us see what is the speed, minimum speed required for this stunt. For this we have to consider one well of radius r. Okay. Now, I am going to consider one motorcyclist making a circular motion in this path. If this is motorcyclist position, we have to first consider what is FBD for the motorcyclist. What is meant by FBD? FBD is nothing but the free body diagram. That is the diagram which shows the forces acting on a single body. All the forces acting on a single body. That is FBD, free body diagram. Then which are the forces acting on this motorcyclist? See, one force is always acting towards the downward position, that is weight force mg. Weight force mg. And the force which is balancing this weight force mg is nothing but the static friction between the surface of the wall and the tires of the motorcycle, that is force of static friction, which will be in a upward direction. I will denote it by Fs. See, this static friction must be there. If it is not there, this downward weight force mg, due to this downward weight force mg, that motorcyclist will slip down. To avoid this, one force must be there which is balancing this weight force mg, is nothing but the static friction present between the tire and the wall of the well. Now another force acting in this, it is normal force. Normal force which is acting on the motorcyclist by the wall of the well. See, if this is wall and motorcyclist is here, then normal force is acting on this motorcycle by the wall, and that normal is acting towards the center of the circular path. See, towards the center of the circular path, and we know that which force is necessary for the circular motion? It is centripetal force. So this normal is providing the centripetal force for that horizontal circular motion. So what I can write? I can write N is equal to mv square by r. That is centripetal force acting on that motorcyclist. It is mv square by r. Let this equation number 1. Now this static friction Fs is balancing weight force mg. Therefore also we can write Fs is equal to mg. Equation number 2. Now see, we know again another thing is that Fs, that is static friction or force of static friction, is always less than or equal to mu s into n. N is normal reaction and mu is the coefficient of static friction. That is Fs is always less than or equal to mu s into n. Now we know all the values. What is Fs here? Fs is nothing but weight force mg is less than or equal to mu s as it is. And what is n here? N is nothing but mv square upon r. M get cancelled. What will remain here? R will come towards left side. Rg upon mu s is less than or equal to V square. If I take square root of both the sides, Rg upon mu s will be in the square root is less than or equal to V. If you observe this equation, you can understand this speed must be equal to, that is V must be equal to or greater than square root of Rg upon mu s. Means this is the minimum speed required by the motorcyclist to make this stunt. Minimum speed. After that he can attain more speed than that minimum speed, but this is the minimum speed must be acquired by that motorcyclist to make that stunt safely. So I can write V minimum is equal to or greater than under root Rg upon mu s. This is the minimum speed must be acquired by that motorcyclist. If you observe this relation also, you comes to know that this speed is not depending upon mass of motorcyclist or mass of that motorcycle. Means this V minimum also not depend upon m. In last equation also, what was that equation? That equation was V maximum, that is safe speed limit, maximum safe speed limit when the car is moving along a horizontal curved road, that was mu s into Rg. Correct? In this also m quantity is not there. Means this speed and this minimum speed is also not depend upon mass of that vehicle. Okay? Now we will discuss one numerical depend upon this formula, that is V minimum is greater than or equal to square root of Rg upon mu s. Okay? So this is one example depend upon V minimum. A motorcyclist is to undertake horizontal circles inside the cylindrical wall of well of inner radius 4 meter. Calculate the minimum speed and the frequency necessary to perform this stunt. See what are the given quantities. It is coefficient of static friction. Mu s is given as a 0.4 and g is 10 meter per second square. Another thing is written in this bracket, C is to be considered as a point mass. Motorcyclist is considered to be a point mass. You remember during the derivation also we have considered that point mass. One point is there. Motorcyclist is considered as a point mass here. You have to remember this. Okay. So what are the given quantities here? See. What is given? Radius is given, that is 4 meter. Mu s is 0.4. G is 10 meter per second square. So what will be the solution? See, when you are solving the numericals in physics, you have to understand the numerical first. What are the given quantities in that numerical? First write down them aside and depend upon them given quantities. Think about which formula I can use here and then put the value and get the solution. Okay. So for this, here given quantities are R, mu s and G. How I can find the minimum speed? We know that formula, that is V minimum is equal to under root Rg upon mu s. So let's put the values. What is R? 4 meter, G is 10 and mu s is 0.4. Now this decimal point we can remove. How we can remove this decimal point? Multiply and divide by 10. So the decimal get removed. Here the quantity will be 4 and in numerator there will be 400. Okay. So see, under root 400 divided by 4, that is there will be square root of 100, that is 10 meter per second. that is V minimum, which must be acquired by that motorcyclist to make the stunt, is 10 meter per second. But again, what we have to find out, it is frequency and a minimum frequency required to make this stunt. So we know another relation, that is V is equal to R omega. Correct? What is omega? Omega is nothing but 2 pi n. So V minimum is equal to R 2 pi n minimum. Minimum frequency. If I take that V minimum, frequency will be n minimum. So what will be n minimum here? N minimum will be V minimum upon 2 pi R. So if you put the value, what is V? V it is 10 to 3.14 into R. What is R here? R is nothing but 4 meter. So if you solve this, you will get the answer as a 0.4 revolutions per second. In 1 second, that motorcyclist can make the 0.4 revolutions. So this is the frequency, minimum frequency that motorcyclist must acquire to make this stunt safely. So I hope you understood this numerical and application of the circular motion. If you like my channel, please like, share and subscribe it, and also press the bell icon so you will get the notification about next lectures. Thank you.